All right, today we're talking about what's called a normal distribution. A normal distribution is what we're going to do on terms of a set of data. We're going to talk about if things are normally distributed or they're skewed, and then we're going to talk about the empirical rule that has to deal with a normally distributed set of data. So, normal distribution again being the main vocabulary of what we're going to be talking about, and then skewed. So, what does it mean to be normally distributed? It means that your mean, median, and mode are all equal. Your data is spread out in such a way that everything lines up, mean, median, and mode, all in the middle, obviously, and then everything comes down from there. I'll show you a normal distributed graph in just a little bit. The distribution, the curve, never really touches the x-axis, and it goes from negative infinity to positive infinity. We're going to use the mean and the standard deviation to find out different probabilities. And then the total number, the total area underneath that curve is 1 or 100%. So remember, we either represent it as a percent or like 25% is really 0.25. So if we add that all up, it will equal 1. All right, so let's classify some data. So here we have some data, and we want to determine whether it's positively skewed, negatively skewed, or normally distributed. Now, let me skip ahead quick. This is a normal distributed graph. Notice how there's a big hump in the middle, and it's roughly equal on both sides. Now, this is a perfect normally distributed graph, but there's going to be some, obviously, with our data a little bit off. It won't be this perfect, but we'll talk about this slide in a little bit. But going back to where we're at. So now we're going to go ahead, and how do we determine this? Well, we need to make a graph. So we're going to make a frequency table. How many times does 31 occur? It's once, and then twice, and then one, so on and so forth. And then we're going to go ahead and graph it. And if we're graphing this, if this is a normally distributed graph, it goes all the way up and then back down. This one is kind of maybe 36 is out of the way, and there should be some more 33s. But the biggest point's in the middle, and it kind of goes up and then back down. If you want to say that we have a little bit more over here, I wouldn't be too upset with you. But for the most part, we're saying that this graph is normally distributed. Let's take a look at this one. This one is definitely not normally distributed. We have all this extra stuff over here on the right-hand side. And so this is skewed. Now the question is it positively skewed or negatively skewed? And the way that we answer that is what part is missing? This negative part, this lower part, is missing. So this is considered a negatively skewed graph. So here again, we have all this stuff on the right side. We're missing stuff on the left side to balance it out. So since we're missing stuff on the left side, this is a negatively skewed graph. This one right here, for the most part, is pretty normal. Again, you're not going to be 100% perfect. We would have liked this 1 point here as opposed to there. But for the most part, this is a normally distributed graph. All right, here's the empirical rule. This tells us how we can use our standard deviation and the normal graph. Now, this symbol here is a symbol for standard deviation. We're going to get way more into these symbols as we get through the statistics course. Standard deviation has this one, and mean has the mu. The mean is right in the middle. And when we talk about, again, being normally distributed, the mean, median, and mode are all right here at the same value. Now, a standard deviation, we figure out how to go ahead and get a standard deviation doing the equation. It tells us how closely packed our numbers are. And so it says something that's within one standard deviation of the mean. So here's our mean in the middle. So one standard deviation up and one down. So let's say our mean is 100 and our standard deviation is 15. So going up to here, this would be 115 on this level, and this would be 85 down here. So between 85 and 115 is one standard deviation. And if we go one more, that would be, we subtract 15 from the 85, and we'd have 70. And over here we would go to 130. That would be 2 standard deviations. And we can keep doing this. And these are the percentages that we have for those different standard deviations. So within 1 standard deviation, we have 68. It's really more like 67% of the population. Within 2 standard deviations, we have 95%, and in 3 standard deviations, we have 99%. So it does go up as we go, but notice this line never goes to the x-axis. It's still, there's always people or the possibility of having parts of the population here, and same thing down at this end. All right, so how do we use this? Let's take a look. We have a normal distributed data with a mean of 66 and a standard deviation of 11. Find the probability that our x value is less than 44. So if we do that, we need to create our own normal graph. And in the middle goes 66. Now remember, they said the standard deviation is 11. So we subtract 11 for 55 and add 11 for 77, then 88 and 44. Now we have that 44 number, and they say what's less than 44. So we want this section here that is shaded in. So we can go back to our original graph here, and here's 2 standard deviations. So we have the 2% and the 0.5% that is still shaded in there. So we have to add, of course, those two together, and we get 2.5%, which is what our percentage that would be less than 44. So doing this again, how can we do one? It starts at 45 and has a deviation of 6. We want something that's greater than 51. So if we're going back to our graph, our table, 45 goes right in the middle. 6 more is 51. And so we want all the points that are greater than 51. So that's the 13.5, the 2, and the 0.5. So that's 16%. Which is what, of course, they say here. All right, let's try another one. Students counted packages of candies. We have 100 of them. Found that the number of candies per package was normally distributed, with the mean being 23 and the standard deviation of 1. So most of the packages have 23 candies. Think of M&Ms or Skittles, whatever you want to do. Most of them have 23, but some have 22, some have 24, so on and so forth. They want to know about how many of these packages are between 22 and 24. Well, that is 1 standard deviation away on both sides. So 1 standard deviation is at 67, 68% in there. Well, so here's 23, there's the 22, and the 24, 21, so on and so forth. So we're talking about this middle area right here. So we're going to add that up. That's 34 plus 34, which is 68. And we want to find 68% of 100. Well, that's actually pretty easy. It is just 68 packages that is what we would expect between 22 and 24. How about those that had more than 25 candies? So if we go back to our graph here, where's 25? Here's 25. And what would have more than 25? Well, there's 2% here and a 0.5%, so 2.5%. Again, we have 100, so 2.5% or 2.5. Students counted the number, last problem, found the number of candies normally distributed with a mean of 23 per package and deviation of 1. How many are between 25 and 21? So we go back to our graph. Here's 25 up here and 21 down here, and we're adding all of this together. 13.5 and 13.5 and the 34 and the 34, leaving out basically this 2.5 over here and this 2.5 over here, which would then give us 95%, which is 95 packages. And that's what I have for you today.